Hi everyone, I'm Lynn Trong with the National Renewable Energy Laboratory, and I'd like to welcome you today to the webinar hosted by the Building America program. We are excited to have Eric Werling and Lena Burkett here today to discuss Building America research. Before we begin, I'll quickly go over some housekeeping. For audio, you have two options. You may either listen through your computer or telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, we will eliminate the possibility of feedback and echo. If you select the telephone option, a box on the right side will display the telephone number and audio pin you should use to dial in. Panelists, we ask that you please mute your audio device while you're not presenting. If you have any technical difficulties with the webinar, you can contact the GoToWebinar's help desk for assistance. If you'd like to ask a question, please use the questions pane to type in your question. You can do that throughout the webinar today. If you're having difficulty viewing the materials through the webinar portal, today's webinar is being recorded and the recording will be available on the YouTube channel within the next few weeks, as well as the Building America website. Before our speakers begin, I want to provide a short overview. Following the presentations, we'll have a question and answer session and closing remarks. We have an exciting program prepared for you today. For more than 20 years, the U.S. Department of Energy Building America program has been partnering with industry to bring cutting-edge innovations and resources to market. This webinar will cover the progress towards achieving goals outlined in the Building America Research to Market Plan and associated technology to market roadmap. In addition, the speakers will guide a detailed discussion on current research projects funded by Building America and how they connect to the plan and roadmap. And now for today's presentation. Our webinar today is Building America Research, Update and Outlook. Our first speaker today is Eric Werling with the U.S. Department of Energy Building Technologies Office. Eric has been the Building America Program Director for the past 5 years. Also presenting today is Lena Burkett, who has been a fellow with the Building Technologies Office supporting the Building America program. With that, I'll let Eric start today's presentation. Eric?
Thank you, Lynn, and thanks everybody for joining the webinar today. We're really excited about some of the new developments with the program and thought it would be a good time to tell some of our followers about some of the new projects that are coming online soon and the way we see our progress so far towards the objectives that we laid out in the Building America Research to Market Plan, like Lynn said, and I'll talk a little bit more about what's in that plan shortly. First, we need to start off with a reminder to folks who are familiar with Building America about what we've set out to do. It's kind of interesting just looking at the title, Building America's Top 3 Building Science Challenges for High Performance Homes. We've known about these challenges for a long time, in fact, through most of the 20 years of the program's history. But it's really only recently where we got strategic and specific about what objectives we need to overcome in order to make high performance more commonplace in the marketplace over the coming decade or so. So we're real excited about the plan that we put in place last year to help us achieve those objectives more specifically. So let me just really quickly review what those are. And they apply to both new and existing homes, although when you look at the roadmaps in their current form, you're going to, if you haven't already, you're going to think that they are largely targeted towards new construction. That's not necessarily our intent, but the objectives are much more clear in the new homes market. We'll talk a little bit more later about what we're thinking about in making the roadmap objectives more relevant for existing homes. But for now, just take my word for it that we're thinking long and hard about both new and existing home solutions. And those 3 solutions include the following. First, moisture-managed high-R envelopes, and what we mean by that is envelope systems, walls, roofs, foundations, that are less likely to get wet on the inside. Basically, we know that the outside of the envelope does get wet, but can we make it less likely for the insides of the wall, roof, and foundation systems to get wet, and then, of course, preventing that moisture from accumulating or condensing on interior surfaces. So that's the bottom line of the first roadmap. Quite a bit of building science associated with that. We can get into a little bit more detail in a few minutes. Second big challenge is to figure out, as we get envelopes to be more efficient, what is actually happening to our ability of our HVAC systems to deliver comfort throughout the year and throughout the house to the occupants. After all, the purpose of the HVAC system is to heat when it's cold outside and cool the inside when it's hot outside, of course. And we also know that not quite, but almost 50% of the energy usage in homes is used in our comfort systems. We've deliberately renamed, we hope it catches on, we've renamed this from HVAC to Comfort Solutions because we think that we need to remind folks that it's about comfort, achieving comfort. We use a lot of energy achieving comfort, and it's not necessarily about the HVAC system, which people tend to think of only as the visible box in your house that you think of as being your HVAC system. So trying to change the language. The low load part here means that as our envelopes get more efficient, if we're successful at the first challenge, then the HVAC systems cannot be designed and operated as they used to because the loads won't be high enough. They won't run very often. They may not actually need enough cooling or heating such that the airflows go down and the dehumidification that might need to happen in hot and humid conditions doesn't happen because you're not running the comfort system often enough. So really the bottom line is that the rules are changing, and the only way to fix the system so that they actually continue to deliver comfort for homeowners in controllable ways is for us to get a better handle on the airflow and indoor relative humidity control challenges that we face. And the third and final challenge is indoor air quality solutions, and we'd like to make them smarter because some of the problems that we've faced regarding indoor air quality systems like ventilation is they tend to be pretty dumb so far. We have started to make some progress in this space, and I'll talk a little bit about it later on. But the idea then, of course, is to do a better job of understanding what makes a home have good or bad indoor air quality, start to move towards being able to actually quantify and measure that indoor air quality, and then also deliver smarter solutions for indoor air quality by controlling fresh air supply, but also contaminant removal and source control. So those are the three big challenges we published in this next slide. We published in the Research to Market Plan in 2015 our strategy for addressing these three challenges over the next 5 to 10 years through Building America projects, and we're just finishing up the second of 2 rounds so far of funding opportunity announcements targeted at meeting the objectives of this Research to Market Plan. The backstory behind where this came from really is that over the first 3 years that myself and Sam Rashkin and David Lee were here at Department of Energy working on Building America and the related programs like Zero Energy Ready Homes, it became pretty clear to us that we didn't have very clear objectives for Building America to manage to. We really wanted to be able to better define what the objectives were for the program so that we could take more proactive control over the outcomes. If we better define the objectives, then we are much more likely to actually achieve them. What we had before, the first 15 and 17 years or so of the program, what we had was some good high bars to shoot for in terms of energy efficiency that we can achieve in houses through better systems, building science, etc. But we kind of left it up, so we'd say something like 50% savings by such and such a year demonstrated in real-world market houses. And that only went so far. I think it was really fabulous for the first 10 or 15 years of the program, and it kind of left it up to each of the individual program participants to figure out the challenges that were unique to their situations, their applications. But in order to actually take this full market, we need to be more coordinated in which challenges we're tackling, how we get them to the marketplace, how they may be impacted by, in one way or another, standards and codes, etc. So we set out to develop this more exit strategy, research to market plan, if you will, and published it in November of 2015. And can you go back for just a second, please? The objectives then, of course, were to get more specific about the goals, to keep in mind that cost-effective solutions that are practical and profitable for builders and home improvement contractors are important, et cetera. Next slide, please. These are the three roadmaps. As I said before, the purpose of this slide is to help you understand sort of the key to the roadmaps if you care to look into them, and to just remind you of the overarching objectives. Standard practices, endpoints, how can we get the whole market to get used to doing high performance, and managing the risks that are associated with getting tighter control of envelope and airflows, et cetera. How can we optimize the performance? That's where some of the technology research and development objectives start coming into play. What kinds of better equipment do we need in order to actually achieve these goals? And then also always remembering that the solutions need to be practical and profitable for builders and the rest of the industry to implement, otherwise they won't take off in the market. So we've used a color code for each of these three roadmaps consistently to remind folks that we have an integrated strategy here. It includes both objectives in the research and development arena, in what we're calling here as a code word, market engagement, for what is it that stakeholders need. In other words, what kinds of information, what kinds of tools that can make it easier to assimilate new technologies, et cetera. And then finally, codes and standards, and they are a big part in what determines what standard practice is going to be. So how can we make some sense out of whether the codes and standards are encouraging the best behaviors? Can we help industry standards to do a better job of encouraging better performing systems, et cetera? And so that's the code, the key for the roadmaps. One final thing at the bottom there, you can see that for each of the blocks in our roadmap, we have either a hard line outline around the outside if Building America and the DOE, other DOE programs are taking a lead on achieving those objectives. In other words, we're funding those specific objectives. Or if there's a dotted line around a block, it may mean that we are trying to take an active part, but we don't intend to play a leadership role, and so we'll be very guarded about how much funding we dedicate to those activities. There's a bit of a gray area between the two, because many of these objectives are really best accomplished through a partnership between the public sector and the private. So, but that's just sort of an overarching way to look at the roadmap. So let me briefly sort of flash them in front of you so you can see what they look like in general if you haven't looked at them before. The first one, the high performance moisture managed envelopes, includes two major types of objectives. How do we get a handle on what the moisture risk management issues are when specifying higher performance, in other words, higher R value and tighter enclosures? And then second of all, can we help the industry to do a better job of identifying those best practice envelope solutions and figure out how to get them better integrated into voluntary program standards and then encouraged by codes in the long term. So that's the objectives in a nutshell of the high performance moisture managed envelope roadmap. Next one is the optimal comfort systems for low load homes roadmap. That has two components also. System design, there's a good design or a bad design of your comfort system can make a huge difference in how well the installed system actually is capable of delivering comfort efficiently and effectively to the occupants where they are. So and then the systems themselves and how they operate, and whether or not they can actually respond to conditions in intelligent ways, including occupant preferences. So those two things, the design process and the capability of the equipment to get more intelligent. Those are the two types of objectives that we've set up, and you can read the fine print. Each one of these blocks, by the way, in the roadmap plan document includes a handful of objectives. Most of them have about 4 to 6 or so objectives associated with them that give a lot more clarity of what we're thinking is needed in order to achieve the overarching objectives of each block. Next roadmap, the last one, is the indoor air quality solutions roadmap, both optimal ventilation and indoor air quality, and we've divided that into 3 different areas. Targeted pollutant solutions are recognizing that a lot of times dilution is not the best solution to indoor air pollution. Pardon my rhyming. The most prudent indoor air quality strategy we've learned over the years, and decades actually, is can we identify pollutants that are causing problems first and then either prevent them from happening in the first place or control them at their source. So that's what we mean by targeted pollutant solutions, and they're sometimes best thought of as a particular pollutant, like radon, for instance. That's a targeted pollutant solution where you know what the pollutant is, you know where it comes from, and you go figure out how to remove it so that it doesn't get into the house. Sometimes it's more a bunch of pollutants, but we know where they're likely to occur. So for instance, kitchen activities can produce a lot of pollutants that have some known chronic health impacts. And so if we can lower the amount of exposure to kitchen pollutants by effective exhaust ventilation at range hoods, then we can reduce that exposure and make a healthier indoor environment. I was just illustrating there 2 types of targeted pollutant solutions. One where we don't exactly know which pollutants are likely to be in any one house, in any one situation, but we know how to remove the pollutants at the source, so we focus on the technology, whereas another one is more focused on what do we know about the specific pollutant and how it gets into the house. And it runs the gamut in terms of targeted pollutant solutions. The second area, smart ventilation, is really about our ventilation systems today. While they now exist, whereas we used to rely on just natural infiltration of outside air without any ability to control it in any way. Now we have ventilation systems, but they're not very smart yet. We don't have the ability yet to reliably vary the amount of ventilation depending on the conditions, like for instance how many occupants are in the house, what's the likelihood that infiltration might be helping us out, etc. So a host of solutions that we've identified that can help us make smart ventilation for general pollutants in houses so that we have fresh air all the time. And then finally, how do you make sense out of all of these different types of pollutants so that we can help the industry to better manage indoor air quality? In other words, some types of how does one pollutant compare to another in terms of its health impacts, and can we actually move towards effective valuation metrics around indoor air quality benefits so that we know this house is better or worse at managing for indoor air quality issues. So those are the 3 roadmaps, just high-level sort of summary. Next slide, please.
Okay.
We're going to talk. Oh, sorry.
Go ahead. Do you want to say anything before we get into the project?
Introduce you there.
Okay.
Yeah, let me really quickly introduce you, Lena. And what we're going to do now is talk about the slides. The next 15 or 20 slides or something are little vignettes of each of the projects we have going on right now that we wanted to highlight. They include, we're separating them by the roadmap since that's the focus here, but they include projects that are Building America team projects that we awarded in 2015, so they've been ongoing for about a year. There's also projects that we're really excited about. We are just in the process of finalizing the agreements, 8 of those in the 2016 funding cycle. And then we've also interspersed 5 of the national lab projects that are are really kind of key projects in the Building America program strategy. They all together help us to achieve these roadmap strategies. So we're going to talk briefly about each one of these projects. Lena and I are going to trade off so you don't have to listen to my voice droning on for an hour. And Lena is an ORISE fellow I hired here to help out with Building America, and she's been a phenomenal asset to our program. We hired her out of the student design competition a year and a half ago, and her team was one of the runner-ups, and sometimes I think she knows more about building science than I do. So Lena, why don't you introduce us to the first of the projects?
Sure. Thanks, Eric. So I'm going to start off with one of the most intriguing of the new projects in my mind. The University of Minnesota is testing an innovative wall assembly, which is basically 2 thick layers of OSB together, and then exterior rigid foam on the outside with no framing. It's also it's not framing. It's also not exactly a SIP because it's not sandwiching the rigid insulation. So what they're going to do, they've tested this in the field before, but what they're looking at right now with this project is the constructability and the moisture performance compared to an Energy Star wall of similar thermal performance. So they're going to be testing side by side the same home designs with these two different wall systems, and looking at the quality assurance level of it. The hypothesis is that this will be more easy to control the quality of, because you would have only one envelope contractor, because it's just one kind of system. And then also looking at the cost, the timing of the construction, and then the kind of more longer term moisture and energy performance of that wall system. Eric, you want to take the next one?
Yeah, so the next one, that was pretty cool, Lena, but maybe I can top that. Home Innovation Research Labs, they don't like to be called by their acronym, but they like to be called the Home Innovation Research Labs, and they are formerly the NHB Research Center. This project is a 2015 funded project, and it was really just 3 small projects in the envelope space that they had bid on that all seemed to fit well together, so we combine them into one project, but it's really 3 separate projects. The first one is to support the development of our knowledge base around the moisture performance of different high-R wall systems. So they are doing actually field-based testing of walls that meet or exceed R20, and doing it in a variety of climate zones and different wall systems, and taking the moisture measurements. That's the bottom, just moisture meters are pictured in the bottom picture. The second one is a completely separate project where they're doing some fine-tuning to the testing for market readiness of a new framing technique called extended plate and beam. And really that system is a system where they have 2x6 bottom and top plates and beams such that they can, and then 2x4 studs in the cavities, so that they can put 2 inches of rigid foam insulation into the wall without taking away the nailing base, so that it's actually much more similar to typical construction and an alternative way to get exterior continuous insulation into the house, so that we can get tighter, more moisture durable exterior walls built up without any significant increase in cost or significant change in framing processes once the framers have learned how to do the details. So that's a pretty exciting project for some participating builders who would prefer to keep what they're good at in terms of framing, but add the insulation to that. The third of those 3 projects is also an envelope project, but it's focused on a retrofit application. This is up the top of the 2 pictures where they're using a nail-based product, which is, I think it's 3 or 3.5 inches of foam insulation panelized with OSB, and those panels are basically attached to the roof deck during a roof replacement job. So the roofing contractor will take off the old roofing shingles and paper, apply the nail-based insulation panels to the roof system, and then make that whole roof an insulated roof deck instead of what it was before applying the new asphalt shingles. So although it doesn't have to be asphalt shingles, it could be any kind of roofing system. And so the value here is that if we can proof of concept here where the roofers can actually get involved in adding significant amounts of insulation to the attic roof system without having to go inside the attic and do it during a typical job, a typical re-roofing job, then we might actually be able to insulate millions of attics a year without a hugely new business model approach. So 3 exciting specific projects that will help us move towards our roadmap goals in the envelope space. Lena, back to you for the next one.
Okay, this is another one that I am really excited about. Also has to do with attics and insulation, both of new construction and existing homes. So what Building Science Corporation is doing is testing a membrane, what they call a diffusion vent, at the ridge of a roof that's insulated with fibrous insulation. This diffusion vent would be similar to a house wrap. And the idea is that the moisture that builds up inside the attic tends to migrate to the ridge of the roof, and this relatively narrow kind of diffusion vent strip here would allow that moisture to escape, allow any wetness that gets into the attic to be able to dry out. And so there's going to be 3 winters of data on this in a new construction home, and what they're going to be doing there is really stressing the system and seeing if it will sufficiently be able to dry out in normal conditions, and then in high humidity, interior humidity conditions, and then in conditions where there is more air leakage from the living space. And then the other part of it that I'm especially excited about is the existing home application of this. So they'll be testing it on an existing home. Basically the same setup, but the advantage here, especially, is that it's a very minimally invasive retrofit measure, and it will allow them to use a much more cost-efficient material for the insulation rather than a vapor impermeable insulation that is typically being used. So this one has both advantages of new construction application and existing home application, so we're excited to see what happens with it.
And Lena, isn't the new construction part of that project is in Chicago, and but that's following on what we heard was a successful implementation of the diffusion vent technology in hot and humid climate test houses in previous years. So we're not just starting with a brand new application, we're really seeing if it will work nationwide.
Correct. Yes, this is something that's been kind of developed over time for a while now, and this will be this test will be in an occupied home, which is another difference between the last test. So again, they're really looking at those stressors of humidity and air leakage that you would find out in the field, and to see if it will be able to perform as well as it did in the previous test.
So the next one, Center for Energy and Environment, with some help from the UC Davis Western Cooling Efficiency Center and AeroSeal, Building Knowledge. They're going to be testing the AeroSeal technology, but for the purposes of sealing a house, not just the duct system for which the technology was originally developed. This is a pretty cool concept, and it's already been tested to validate that it works. The cool thing about this approach is that you do the air sealing while you're doing the blower door test, so you can actually dial in the air tightness that you want for the enclosure and then just run it until it meets that level, and then you stop sealing and you're done. The unknowns about that have to do mostly with the production process for builders, and it's primarily driven by the amount of time it takes to blow the aerosol to fill all the cracks in a house. It is dependent on how big the holes are in the house. So there's this sort of game that you have to play to figure out, well, how much of the really big holes should we fill before we do the air sealing, so that we can optimize the process. So this project is really about working with production builders in, I believe it's Minnesota and Colorado. I might have that confused. It's one of the C states. It's either Colorado or California. Anyway, California. So they're going to be working with production builders in both of those environments, so they have some variety and they can learn what's sort of the optimal way to factor this technology into a production builder process so that they can optimize the costs of using the technology and regularly achieve exactly the air tightness that you want in the building with and limit some of the tedious labor associated with sealing every crack and crevice in a house. So that's a pretty exciting project because it may well take air sealing into the 21st century. And we'll see how well that works, so I'm excited about that one.
Okay, this is another Home Innovation Research Lab project. The earlier ones that we looked at were started in 2015. These are the brand new recent batch of awards, and so they're just getting started on this specific project. So what they're looking at is they're really trying to tackle the questions surrounding the window installation in walls that have continuous insulation. So some builders are hesitant to use continuous insulation because they're unsure about the window attachments needed and what's been shown to work and what hasn't. And so this study will provide the data needed to really understand which types and sizes of windows should be used, given varying thicknesses of the continuous insulation, and which attachment methods are appropriate, whether they need these kinds of strips that are shown in the slide, or they need to box out the window, or they can install it directly through the continuous insulation into the window framing. So you know, the advantage here is that this is going to be able to enable more use of continuous insulation, which we know to be a very effective way to increase the thermal performance of a home, and could be used as justification to refine industry guidance and code that may be not as clear about what types of installation is allowed in each of these circumstances. So they're working with the American Chemistry Council and with the American Architectural Manufacturers Association, AMA, which is kind of the window industry association. And we are looking forward to seeing the results from this. They're just going to be doing wind testing and structural strength testing to, on a variety of these combinations of windows and insulation. Okay, Eric, back to you.
All right, so this one with Fraunhofer is one of the new batches of Building America projects just awarded. Ink's not even dry on the awards for these. And this was the one project that came through as competitive in the topic 2, where we're looking for solutions that are specifically appropriate for home retrofit activities. And what we're looking for as one of the topic 2 options was, are there better ways to do performance measurement and assessment so that we can streamline the process of doing measurements and assessments and get right to the work of improving the building systems and enclosures. And this project rose to the top there. It's what they call a physics-based interval data model for automating and bringing to scale, really, the home energy performance evaluations. Targets specifically on heating loads, and they're using meter data and connected thermostat data to that stream to correlate it with, hopefully at a relatively high accuracy, such that just with that remotely sensible data, they can actually determine which houses are most likely to benefit from insulation improvements or HVAC equipment improvements and for heating. So there are several other organizations currently looking at similar solutions. This is the one that we're investing in this round, and we'll see how much we learn about how well we can predict savings estimates from heating measures in houses just based on the data that we can collect through systems that are becoming more and more available. So that's a pretty cool thing, particularly for utility programs that want to be able to target their program offerings to only those houses where they're actually going to get the savings, save them costs, save costs for homeowners, etc.
Okay, so this is one of the national lab projects. So far, we've just looked at the team projects from 2015 and 2016. This is actually being done by Oak Ridge National Lab in conjunction with it has some related aspects to some of the team projects. They're working on an expert system for to work kind of as a decision support tool for designers and for builders when they're considering different wall systems. So the idea is that there's so much information out there in all of the heads of these experts, that if you were able to ask them, what new, should I try this new wall system in my climate? I'm not sure, but my client wants, a brick facade or a different kind of cladding, and is that going to work? Just because there are so many of these new innovative wall systems that there may not be a lot of confidence in those systems, until the builder really gets their hands on them. So this will be like a web tool or an app where a designer or builder can input their climate, the type of cladding they want, the type of the dimension of the framing they want, or whether it's SIP or masonry walls, whatever the structure may be, and then go into more of the details of what kind of water and air barrier they're using, what kind of vapor retarder, sheathing, and this tool will generate both a kind of comparison to other walls that a designer might be looking at to assess the potential moisture durability of each of those walls, and also point to guidance on how to mitigate any moisture risk associated with those. So not just giving a flat number without any way to deal with that possible risk, but actually pointing them to kind of proven advice on what you need to focus on during the the building of this, whether in one wall the construction moisture is a big issue, so you need to make sure that keeping all of the materials dry on site, or whether it's more of a installation quality workmanship issue where there needs to be even more detail taken at certain intersections of these building materials. So what we're hoping is that this will kind of provide better informed decisions and a higher confidence in using some of these more advanced high-performance wall assemblies, but it will also have the more traditional wall assemblies that builders are used to working with, so that they can really compare what they would see if they were to change into a more advanced wall system. So that is there's not a year on this one. It's because it's one of the labs. It's been going on for just not quite a year so far. We're getting a lot of stakeholder input on this, if this is going to be helpful for the industry and what really needs to be focused on in this. But I've been working with them on this a fair bit, and it seems to be progressing very, very nicely, and we're looking forward to it.
So I might add to that, Lena, that it is a work in progress, and we will we meaning Oak Ridge will be sometime this fall, I believe, we'll be posting probably an alpha version of the system on the internet for people to play with. If you're interested in being a beta tester and want to provide input to us, we absolutely believe 100% that if it doesn't fulfill some important needs for potential users, then it's not going to be used. It's kind of a no-brainer. So we need to have inputs from people who are interested in these issues of what are a better understanding, what are the moisture durability risks in high-performance walls, and how can we more effectively learn how to manage those risks. That's something that this tool is we're hoping will help to resolve. So we need input from as many folks as we can get during that process. Stay tuned. We'll announce it when it's ready. But if you want to be among the first to test it out when it's ready, just send me an email, and I'll make sure that you're on the list. So, Lena, I think we're done with the envelope system projects, and we're moving on to the comfort systems. Is it my turn or yours?
Yours. Mine,
okay. So the first of the comfort system projects, this is a 2015 awarded project, and University of Central Florida, Florida Solar Energy Center is validating some relatively new, they're not brand new, but relatively new to the industry technologies in the HVAC space, including some variable capacity inverter-driven heat pumps with small duct high velocity distribution, and seeing what kinds of issues happen, what's the relative performance, etc. Particularly with regards to the ability of the system to control relative humidity and what are the issues that show up there. So it's basically taking existing technologies, but ones that haven't been widely adopted and haven't been widely proven to work, and investigating the comfort performance for those systems, particularly for a hot and humid climate. So that's that project.
Okay, and Ibicus is another project from 2015. They had they have two main areas of focus for this. One is what they call a plug-and-play duct system. So this would be a small diameter duct system made out of like a kit of parts. So it would be it would be easier to install, and you would actually do the full duct design would generate what parts were needed for that system, but they would all be very similar throughout the system. So it helps with the installation of the system in smaller cavities or in between floors, so you're keeping more of the delivery system inside the conditioned space. And
I think of that as being like a PEC system for HVAC ducts.
yeah,
right?
exactly. It has a home run or a manifold type design where each duct is going back to this plenum for the air handler, and having its own run, which actually can lead to a higher level of control for each of those duct runs. Being able to
Possibly,
position
yeah, possibly even conquering that the ongoing challenges of multiple zones, right?
Mm-hmm. That's right. So they're working on that small diameter delivery system, as well as evaluating the need for a thermal comfort rating method in the industry. This would be similar to an energy rating method, but allow builders and homeowners to kind of be able to compare those the effects that energy efficiency and comfort have on each other, and be able to make decisions about what measures to pursue based on both the energy needs and the comfort needs as well. So just looking at kind of being able to put some quantifiable ratings around comfort, which thus far, especially with homeowners and builders as well, is right now kind of a nebulous subject that's hard to pin down. So the thermal comfort rating method is trying to accomplish that that process of really being able to compare certain specifications or measures to be taken in a home.
We should stress that that is an exploratory project, that they're not actually developing a thermal comfort rating method. They're exploring the feasibility of it with this project, and so we won't have a thermal comfort rating method anytime soon, but maybe we'll know a little bit more about whether or not, hopefully a lot more about whether or not it makes sense to pursue that in the future. Thanks, Lena. So my turn, and this one, Levy Partnership, this is the only project that's 100% focused, well, it's actually not 100% focused on, I'm sorry, I'm correcting myself as I go. The Levy Partnership has been, in the past, 100% focused on the manufactured housing industry. This project is kind of the culmination of a series of work that they've done in that space to figure out how to attain significantly more energy efficient designs that are practical for the manufactured housing, i.e. HUD code home manufacturers to build, to construct, and do so without a significant increase in cost. We're talking about getting 50% savings or more relative to current state-of-the-art in the manufactured housing for, hopefully not much more than $1,000 per unit, which is a pretty remarkable amount of savings. Of course, it has envelope components to it, HVAC system components to it, and this particular project is focused mostly on the latest development in their integrated design approach is to figure out if they can actually get the HVAC system to be installed in the factory, in this case a mini-split heat pump, with mixing transfer fans in the house to distribute the conditioned air throughout the house evenly. And they're taking measurements on a couple of test houses to test the theory that could happen. The reason why this is so important in the manufactured housing industry is because current practice is that the HVAC system is actually the only part of the house that's the main part of the house that's not quality controllable from the factory because the HVAC contractor comes in after the fact and installs the system. And sometimes disrupting the integrity of the building enclosure in the process, because not all HVAC contractors know how to do their job without cutting big holes in the envelope, etc. So the hopes are that we can get a tighter control of the HVAC installation process in a factory setting for manufactured homes, which we hope would lead to cost reductions, and then also higher efficiency equipment, and achieve the same level of comfort but a lot more quality control in the process. So hopefully that will work well. They're in the process of testing the systems in the existing houses now. Oh, and they all are also, there's a task in this project where they're going to try the same approach in Habitat for Humanity houses, which are not manufactured housing settings or site-built. So that's it for that one.
So this is another one of the newer projects starting in 2016. Stephen Winter Associates is looking at the development of an integrated ERV and heat pump. So the idea here is that the typical central ventilation methods would be a separately ducted ERV or HRV that has a separate set of separate distribution system from the heating and cooling system, or doing a central fan integrated supply where they put a hole in the return and attach the ventilation system to that. And those each have some some disadvantages, either cost-wise. The two separately ducted systems are going to have a higher installation cost, and there's also the aspect of if the correct size fan is running at each time with the CFIS system, so which may rely on the central air handler fan rather than a more appropriately sized HRV fan, or ERV fan. So what they're doing here is actually combining those systems using variable speed fans both in the ERV and in the air handler, so that they can really dial in that controllability and generate the ventilation that they need, or the air conditioning, heating that they need at low energy level. So they're going to be testing these in first unoccupied and then occupied homes, working with Mitsubishi to do this, and they expect that they will be able to show a reduced upfront cost as well as lower energy use across the year than those two other typical central ventilation methods.
Yeah, if they pull that one off, that'll be pretty exciting for production builders in particular, but even existing home replacements for, where we might anticipate doing air tightening in the future, adding the ventilation system in the process of adding your, replacement HVAC could be a very exciting opportunity for both new construction and retrofit. So we're pretty hopeful for this one.
And on the new construction side, I think one of the kind of reasons behind this is that the heating and cooling loads are getting so much lower with higher insulation values in the envelope, and as the homes are getting tighter, the ventilation is needed more to be able to fulfill what the infiltration used to. So those the required distribution systems of each of those functions are getting closer and closer together. So the idea is that if they're close enough together to share this distribution system and correctly deliver both the ventilation and the heating or cooling to all of the areas of the home sufficiently, then yeah, this would be a real advantage.
Seems like a no-brainer, but it actually turns out to be quite complicated because you got two variable speed fans that have the potential to fight each other. So they're going to be working out some technical challenges, but we're hopeful for them. This next project is a project that has actually recently been mostly completed. It's an NREL project in which they're trying to figure out how to create a simple dehumidification sizing standard, because one does not exist. So the next step, they've already created a draft, and the next step is to work with industry stakeholders to figure out if we can get that incorporated into design procedures so that we can actually more reliably size dehumidifiers to the right loads for a house, not having to oversize dehumidifiers, etc. So there's several benefits that will come from having a design standard around that, and that's the focus of that project. It's part of the the relative humidity control aspects of optimal comfort in low load houses. So we might almost be done. Oh yeah, okay. Last one.
Well, yes, last one for the
last one for comfort.
Comfort. Yep. So this is one that that PNNL is working on, a white paper on the what we're calling intelligent residential comfort control applications. That moving away from the term smart HVAC for reasons that will be kind of clarified in this report when it comes out. But what they're doing is looking at both kind of the technology components that are needed for various applications in residential HVAC that would be beneficial as these technologies are being developed. Basically, right now there's a lot of new smart technologies being developed, but there hasn't yet been kind of a framework for how all of those are going to work together in a residential application in a way that's going to benefit the occupant. Right now, there may actually be products that are going to fight against each other, or not communicate with each other because of whatever communication protocols they're using. So this is basically breaking down these applications into what specifically do we think is needed for each of those, and where are the gaps technologically and also the market needs in that framework. So looking at applications in the operation kind of phase, as well as commissioning and maintenance needs. So kind of through the whole life of the HVAC system. So this is one that I think is really going to continue to develop as the market and the knowledge and clarity on this subject continues to grow.
Yeah, it's our attempt to. Yeah, it's our attempt to connect. I mean, we have, a separate program in the Building Technologies Office called the Emerging Technologies Program, and they have roadmaps for technologies. And there's currently under development a sensors and controls technology roadmap, which it's exciting to imagine what advanced sensors and cheaper sensors and peel and stick, et cetera, those kinds of sensors and controls could do for us in the HVAC space, but they stop short of actually analyzing what are the applications that are of the future that are needed, and what's the state of the art of current applications. So we're trying to bridge that gap between the Emerging Technologies Program and Building America and the Deployment Program by laying it all out in a framework that makes sense for the whole what we call the Building Technologies Office ecosystem. So we're hoping that work will help us to play together better between the research and development space and the deployment and Building America real world stuff. So that's our hopes with that project. So now we're on to the indoor air quality solutions, and we're getting close to an hour, so we're going to try and wrap up these really quickly. First one of the indoor air quality projects is the South Face Energy Institute, and they're going to be working closely with Lawrence Berkeley National Lab on another project we're going to show you in a minute to do several different things. They're going to be working with developing indoor air quality assessment protocols for the pollutants of concern that can help us, figure out how to cheaply but accurately measure the pollutants of concern in houses and to benchmark these IAQ metrics in both new and existing homes. They've got both production builders and weatherization type contractors involved in field testing these IAQ assessment protocols. They're also going to be focused on a humid climate, so a big issue there, of course, is what's the interplay between ventilation needs for fresh indoor air quality and minimizing the amount of relative humidity issues that happen when you introduce warm, humid outside air. So they're going to be working in all of those spaces in real houses, and hopefully that will make the IAQ score development that we'll explain in a minute a more practical and useful tool. So that's, I think, all I want to say about the South Face project. That hasn't been finalized yet, but we're getting close.
Okay, GTI, the Gas Technology Institute, is testing a retrofit method designed to improve the IAQ as well as the comfort and energy efficiency in an existing home. So, the idea is that in some cases in retrofits, IAQ is a bit of an afterthought after the air sealing, duct sealing, and equipment change out is all done. Then maybe they'd go in and test and see if there's still enough fresh air, and then deal with the need for ventilation after that. So what GTI is trying to do is kind of get in front of that by looking at the kind of integrated systems, focusing on the 3 air streams that are affected and affect the fresh air and whatever may be changed in the retrofit. So that's ventilation, infiltration, and duct leakage. So they're designing this new method of retrofits that would look at that in advance and be able to pinpoint the areas to make improvements in air sealing, duct sealing, etc. That would result in an improved IAQ. So they're testing this method in 20 existing homes and then comparing it to the results of 20 typical existing home retrofits that use kind of more conventional method of implementing those retrofits. Measuring CO2, radon, formaldehyde, humidity, among maybe a couple of other contaminants, and doing this to develop some guidance and best practices to be used throughout the retrofit community.
Here's a new project, 2016, just being awarded now, where Newport Partners, in partnership with Broan-NuTone, is going to be developing what we think of as the next generation of kitchen range hoods. This is an exciting one because there's increasing evidence that that particulates are one of the, especially PM2.5, the really small suspended particles that can make it deep down into your in your lungs and stay there. There's increasing evidence that those types of airborne pollutants are among the greatest health impacts. So minimizing exposure to those small particulates is a desirable outcome, and we already know, of course, that exhausting kitchen, cooking effluents to the outside is a good thing. It's already included in the standard. Another thing we know, though, unfortunately, is that most people don't use their range hoods because they're noisy. We also happen to know that a lot of range hoods are not particularly effective at what we call capturing the pollutants at a high efficacy. So what the Lawrence Berkeley National Laboratory, separate from this particular project, has been doing is testing range hood efficacy, what we call capture efficiency, in a laboratory setting so that we can develop an ASTM range hood test method. I'm flipping between two projects because they really are sort of two different parts of the same challenge. It's a targeted pollutant solution. So LBL's doing the development of the range hood test method, and the manufacturers of the range hoods are actually on board with this, because if they have some measure with a standard for testing their range hoods, then they're happy to make better products. So that's what LBL's doing. Then if you flip back to the previous one, Newport Partners is on the manufacturer side. How can we help to develop a range hood that's not just high capture efficiency, but also smart enough to work whenever there's a cooking event happening, to do it automatically and to operate at a low enough sound level that people are not going to disable it. So really practical criteria for success in here, and they put together a great proposal for how they can develop a product with a little bit of help from DOE to fill that niche, and hopefully the industry will copy that, and we'll be able to have more effective range hoods installed in houses in the near future from here on out. So that's what those two projects, they're not specifically, they're not tied together legally in terms of being, they're two specific separate projects, but they're roadmap projects that work well together. So let's get
one
back
thing
to,
you can, just going to add a little bit, you can see on the Newport partner in the success metrics, they're striving for 100% capture efficiency. And so, like Eric said, that relates to the ASTM test method that LBNL has been working on. And you can see that they've tested a wide range of different range hoods out in the market to evaluate that capture efficiency. And what I think is really exciting about this is that it's going to be able to advance the market in a way that will really benefit the indoor air quality for these occupants. Right now, the range hoods are really only sold based on the fan flow and not so much the capture efficiency. So a consumer who's trying to get very good air quality in their kitchen might be drawn to a high CFM fan, but that may not actually deliver the improved IAQ performance. It may instead just increase the energy use and require more makeup air to as a result of that higher CFM air
right,
flow.
and you can see from the chart that the results are all over the map. I mean, there's some products that are practically capturing nothing. It's pretty amazing what the variation is here. But we can also see that it is possible to get 100% capture efficiency. So if we can move all of those data points up much closer to 100 with these activities, we'll be improving indoor air quality in houses around the country. So it's and hopefully without increasing energy efficiency, we might even reduce the energy load related to these. So let's move on and wrap this thing up. We talked a little bit in the I talked a little bit in the IAQ roadmap about the IAQ valuation, and this is just a little bit more details about what we're doing in the IAQ score. Am I going out of order, Lena? I'm actually trying to get us done with this really quick so we can have time for a few questions to get through the last few. Okay, so I'm going to, I think, leave this one at that because I already sort of addressed the topic of an IAQ score. But like the offer to you all to beta test the envelope design tool this fall. At some point soon, I don't know if it'll be this fall or maybe in the winter, we're going to have LBL is going to have ready a draft IAQ scoring methodology, and we're going to want to have some vetting with key stakeholders. So if you're interested in this topic, stay tuned, and hopefully you'll be able to comment and help make it better. So I think that's the end of the projects, right? Yeah, and here's a nifty little animation to show how we are a sort of a portfolio program. We're touching on with projects on in each of these areas, envelope, comfort, and IAQ, and obviously to get high performance home you have to address all three of those issues. And we're starting to get into the home improvement RD&D projects with the Fraunhofer home performance measurement project. So we're making some strides. I'm really excited about the projects that we have in the hopper now. The last little bit of this presentation is about, well, what's coming next? We've sort of summarized it into these 2 points. There, as much progress as we've made and are currently making with these projects that are ongoing, on the roadmap objectives, there are still quite a few remaining gaps in the roadmaps, and we can highlight what some of those are going forward. And of course, those will be, back up please, of course those will be, the remaining gaps will likely be focus areas for us in upcoming FOAs. The other thing that we're going to increasingly pay attention to is how can we apply these challenges and the solutions to existing home situations which have unique challenges associated with existing home transactions, home improvement transactions like HVAC replacements, etc. So we're going to be looking for solutions where we can apply high-performance home solutions in existing home through existing home improvement transactions. So that's, in a nutshell, that's our strategy going forward. We're going to continue to work on the roadmaps. We're going to finish what we set out to do with those roadmaps, but we also have to start to transition towards how do we make all this stuff relevant for the existing home market. So in a nutshell, that's kind of our strategy for the next few years with Building America. Next slide, please. So how do we identify the remaining gaps? I picked this thing off the internet just to sort of remind folks that if you've heard of the Crossing the Chasm, I first heard about this from my colleague Sam Rashkin, a book by Jeffrey Moore written back in 2006, and he introduced this concept of while the bell curve of early innovators, early adopters, early majority, late minority, this is sort of a kind of a bell curve approach to segmenting the market in terms of new technologies. And what we've been doing with Building America is really focusing on all the stuff to the left of the dotted line. It's really those early builders and contractors who are interested in better incorporating building science into their designs, making better homes that perform better, deliver better value, and do it with less energy consumption. And we've got a whole bunch of great solutions. You can see it in the Zero Energy Ready Home parade of homes. You can see it in the solutions that are laid out in the Building America Solution Center. So we have these solutions, but we also have this big chasm between those early adopters and the mainstream, who in the new construction market tend to sort of just follow what's required by the code. So how do we bridge that gap? Well, there's a bunch of issues, but mainly what we're looking at is with the roadmaps is helping to identify objectives that help us to overcome the cross that chasm, taking the high performance best practices that we have been demonstrated with Building America. How do we help to overcome both through technology, better technology, through better information and tools for industry players, and then also ultimately through better standards and codes. And that's what we've been talking about today, projects that help to bridge that gap to prove that new technologies can work better, to give industry partners the tools, the knowledge, and the ability to work within standards and codes that encourage those better performing technologies. So that's kind of what we're about with regards to identifying the gaps. If we could move really quickly to the next couple of slides. We're showing here in these slides, and we don't have a lot of time for it, so I'll try and breeze through it in about 5 minutes really quickly, but I think the slides will be available for you to look at more carefully if you'd like. The remaining roadmap objectives in the high-performance moisture-managed envelope space really kind of boil down to these high-level biggest remaining gaps, and we've classified each of these remaining gaps in terms of both new construction and existing homes for the reasons that I mentioned before. In the new construction for envelopes, we're looking for filling remaining gaps in knowledge around lab and field measurements of moisture risks in real-world conditions. We know we don't have enough of the wall systems and attic systems, et cetera, in the current mix of projects. So we know there are going to be some remaining knowledge gaps in that space. Also, we need to have some more validation information on the best envelope systems that meet the high performance targets at low risk and affordability within the marketplace. For existing homes, we're starting to turn towards those questions about what solutions are needed, and it sort of boils down to a couple of things, although there's a lot of stuff in here. How can we get more scalable envelope upgrades through home improvement transactions that manage these risks and are affordable in the marketplace and deliver the improved energy performance? And then how can we develop and support with projects the transaction-specific expert guidance so that people won't get in trouble when they try new stuff? You add a bunch of insulation to a house. Does it change anything? Does it potentially change the indoor quality or the performance of your HVAC system? Well, we know that it might, and so how can we provide expert guidance to the trades so that they won't be scared of doing upgrades to homes? So that's kind of the road forward for our envelopes for the next few years. For optimal comfort systems for low-load homes, we've kind of highlighted with this slide animation the things that we're focusing on the near term. A bunch of stuff here. We'll summarize in words what they are on the next slide. New construction, it's affordable low-load HVAC and dehumidification solutions. We've come a long ways in terms of better understanding what improvements to the design standards are needed, but we don't really have a wide variety of effective dehumidification solutions that are easy to specify and affordable. So we need some more of those. We need smarter systems that include things like automated fault detection, optimization, connected learning, et cetera. And then a big focus will continue to be ways to have better distribution comfort performance. For existing homes, the twists are a little bit refined, but a lot less known about what the actual costs and benefits are associated with getting the basics here are really how can we evaluate whether or not systems as installed are working. Can we find better tools, what we call better commissioning tools, which could also apply to retro commissioning and assessment of current systems that are cheaper, faster, more accurate, that help us to actually diagnose problems in a more expert way with less labor. How can we scale up upgrades to distribution systems? We know there's a lot of leaky, wasteful duct systems in houses around the country. Can we come up with better ways for contractors to do a lot more improvements to those types of systems? And then again, just like the envelope, the last bullet I had on the envelope one, can we come up with expert guidance that's transaction specific for HVAC repair and replacement jobs. So we can arm the HVAC industry with some expertise that allows them to actually incorporate building science into standard HVAC replacement activities. So the last one is the IQ roadmap. Biggest news here is the one on the bottom there, develop IQ baselines, along with some of the other things that we've been working on. Next slide, please. So the summary of the issues that we're most interested in right now is we are, particularly with regards to ASHRAE Standard 62.2, we are kind of at a point where there is an unresolvable argument between the pragmatists in the industry and the precautionary principled health advocates in the industry, where we are still arguing about what's the right ventilation rate, and there's good arguments on either side. When probably the truth is that IAQ is much more complicated than that question, what's the right ventilation rate? And since we don't actually have enough data to be able to characterize homes in the population of new homes, for instance, we really can't solve that debate. So what we need is better baseline information on what pollutants we're finding in modern homes, how effectively are the systems that are being installed for indoor air quality purposes of doing the job or not, and then that can inform improvements to the industry standards that are applied to protect indoor air quality. We will continue to need improved targeted pollutant solutions like the range hood solution that we talked about before, and we have made some progress in smarter ventilation systems, but there's a long ways to go. We're starting to focus more and more on occupant-based smart controls, and then also connectedness of ventilation systems to other systems in the house. And then finally, with existing homes, IAQ solutions, that we also need targeted solutions, but they have to be adapted to the high-impact transactions in the existing home market. Same with the smart ventilation systems, and once again, the transaction-specific expert guidance. So I think we're at the end of the presentation, and I think I'm handing it over to you, Lynn, to do the final stuff, and we might have time for a couple of questions, right?
Yep, we do. For everyone in the audience, please continue to send in your questions. We'll take them through the end of the next 8 minutes. If we don't get to your question today, we will follow up separately. But Eric and Lena, thank you for the information. We'll start with a couple high levels before we hopefully get into a couple more technical questions that have come up. Can you provide just a very basic summary of how the projects that you talked about were selected and the time frame? How long will they be funded, whether they're the 2015 projects or the 2016 projects?
Yeah, I can do that really quickly. So both the 2015 and 2016 funding cycles funded projects that were targeted at 2 to 3 year periods, and most of them are 2 to 3 years. So that's we don't specifically say how long one project should be. So that's the time frame for most of these projects. They are cooperative agreements, and we'll talk more in the webinar next week about the process that we go through for selecting projects. So I'm not going to belabor that point right now.
And because we are a little tight on time, the URL that you see there, buildingamerica.gov, that is where the presentation slides will be posted under the Meeting and Events tab. But Lena, if you can go back to the next, the upcoming webinar, we're going to hold it there while we answer the last few questions so that everyone in the audience is aware of the time for next week's webinar. So another high-level question for you, Eric and Lena, if you could just answer it briefly, is that because we have been getting some recommendations, what's the best way to submit industry needs for incorporation into the roadmap?
I'm not sure I understand the question. Could you repeat that, Lynn?
Sure. If the industry would like to have input, what was the best way for them to do that in terms of the process that you're developing now for the roadmaps and evolving them? Right.
So there's two mechanisms. One more formal, where we will continue to incorporate periodically into our planning process, stakeholder meetings in which we'll be soliciting input, through meetings, etc. And then informally, my email door is always open. So I will commit to considering any suggestions that come into my email box. I'll let you know I've received your suggestion, and I'd much rather receive a good suggestion in an email than junk mail. So fill up my mailbox. Go for it.
Okay, great. Let's go ahead and start diving into the more technical ones. And I'm going to just read this straight. So Lena or Eric, whichever one of you want to tackle it, that'd be great. Why is the high-performance solution for affordable housing using the success metric of 50% better than the 2009 IECC versus a more up-to-date version of the building code?
Well, that particular project is a HUD code project, and the current building code is the 1994 HUD code. So that metric will likely change if and when the HUD code is changed, and that's an ongoing activity, but it's not a Building America controlled activity. So they're currently building HUD code homes to a 1994 energy standard. That's the reason for that. I mean, it's actually quite an aggressive target.
Okay, the next one that we have for you is a question. I think it's related to the PNNL project that you had talked about. So the question is, the ASHRAE TC 810 is submitting RTAR on this topic and would like to include this as part of it. Is that what you understand as well?
We have not coordinated this activity with that particular RTAR, but it sounds like a good thing. I'm an ASHRAE member. I'm a member of 2 ASHRAE committees, so I'd be happy to pursue that one. If, Lynn, you can send that comment to me, I will look into that.
And Eric, do you want to talk to how, if the folks in the audience have ideas, how would they what is the best way to obtain future DOE funding, whether to commercialize their project or support their project research-wise in some way?
Yeah, two answers to that. One is that we are going to be talking a little bit about the sort of the funding process next week. So the slide that's showing right now, just make sure that you attend that webinar to get a much more detailed sort of sense for how we do the FOA process and what makes for a good, strong Building America project proposal. So pay attention then. And then there are also other funding mechanisms. So it all depends on your idea. And they're like anything else, there's never enough money to go around. So it's going to be competitive. And we'll talk more about the Building America funding process next week. But if you want to get on the building technology, the other building technology offices, distribution lists, you can go to each one of their websites. The Emerging Technologies Program, for instance, if you're somebody interested in new product development, then you're going to want to be on their mailing list so you know well ahead of time what they're doing with requests for information and their roadmaps for the different technology areas, and obviously ultimately the FOAs. In recent years, the Emerging Technologies Program has had more money available, quite a bit more money available actually than Building America. On the other hand, they're focused on technologies in both the commercial and the residential space and longer-term technologies. So, there's no one answer to that question, but stay tuned and maybe you'll learn a little bit more about how we do the Building America funding process next week.
Great. Thanks so much, Eric. And thanks again to Lena as well for providing great information today. Because we are out of time, thank you to everyone who participated today and submitted questions as well. We will follow up. If we didn't get to your question today, we will follow up after the webinar. On behalf of the Building America program, I just wanted to thank all the speakers today and the attendees. We had a great dialogue, and as I mentioned before, you can go to the buildingamerica.gov website to find the slides and the recording of this webinar in the next couple weeks. If you have any additional questions, feel free to reach out to us as well. Thank you, everyone, and have a wonderful week.